This is an example of a paired samples t-test, and we're going to choose a research question, look at some fake data, and then we're going to practice the analysis and the graph that goes with it. So imagine that we are a GRE preparation company. The GRE is the Graduate Record Examination, and it's an exam at the end of college that's similar to the SAT that you might have taken to get into college. So most graduate schools require it, and students are really interested in getting high scores on it. So you are a company that develops workshops and training and practice programs, and you would like to have some data to suggest that your program significantly improves people's scores compared to what they would get if they didn't take the program. So because you can't randomly assign people to your program or not, the best choice that you have is to be able to look at their scores before and after taking your program. So you take 20 of your recent clients and you ask them before they start, what did you get on the GRE when you took it before you took our course? This is labeled as GRE Pre. Then you ask those same participants after they finish your course and they take the GRE again, what did you get on the GRE this time? That's GRE Post. Our null hypothesis, or the assumption we're starting with, is that there's no difference in GRE scores between the before and after of the course. The alternative hypothesis, you as a company think, that the GRE scores will be higher after taking the course than they were before. At least you hope they are. So the data set we're using is listed here, and you can use it to follow along. So repeated measures data or within subjects data like this is set up that each row represents one person. And for example, let's say this is Joy, and Joy got a low score on the GRE the first time and a higher score the second time. And then let's say that this person down here is Tom, and Tom got a relatively high score on the GRE the first time and only slightly higher the second time. So in a paired samples t-test, we're comparing each person's score the first time to the second time. They're not really competing against each other. So what we're going to do is go to Analyze, Compare Means, and choose Paired Samples t-test. Okay. I'm going to reset this here. What we see is a paired set of variables, and we're asked to list variable 1 and variable 2 in the pair. In this case, since we only have 3 variables, it's pretty easy. But you always want to remember that these are the pre and post, or the variables that each participant experiences at different points in time. So they should both be scale variables, and we list them in here like this. There's not much else to do for the paired samples t-test. Let's go ahead and hit OK and look at the output. Okay. So this is just a quick reminder that we had 20 participants or 20 clients, and on average their score at the beginning, before they took the class, was 144 on the GRE. And afterwards their score was 147 on average. So we see that they went up, but we don't know if that's a significant difference from the previous or whether that's something that we might expect just by chance. So let's take a look down here at the paired samples t-test. The paired samples correlations SPSS will give you, but this isn't really particularly helpful to us. Of course, we assume that people have a correlation between their pre and their post scores because it's the same person taking the test. So we'll just ignore that for now. Down here at the paired samples test, these are all descriptions of the differences: the mean difference, the standard deviation of difference, the standard error of the mean, and the 95% confidence interval of the difference. What we're most interested in here is, does this difference represent something by chance or something that's not likely due to chance? So we're looking at the probability or the significance value of our t statistic with this many degrees of freedom. So our significance level that we have set as a rejection criteria is a probability of 0.05 or less. And what we see with this probability of 0.08 is that even though it's fairly low, it's still above 0.05. So much as we might be disappointed as a company, we can't reject our null hypothesis based on the standards of typical psychological science. So we can't say that this kind of a difference, this magnitude of difference between pre and post is something that is very likely due to chance, or very likely not due to chance. So we can't say much about it. We fail to reject the null hypothesis. The t-value tells us how big is that difference, and a t-value of 1.8 is not that big. If we saw a larger value, then we would also expect to see a larger significance level. Conversely, if we saw a smaller t-value, we would expect to see an even smaller significance level. This depends somewhat on the degrees of freedom. We only have 20 participants, but in this particular case, because we have 20 and it's a within groups design, then we subtract only one of those participants to calculate the degrees of freedom for the t-test. So this is what we would report, and sadly as a company, we're not able with this data to make any claims that people significantly, consistently improve their scores after taking our test.